Hey guys, today LeetCode 236, lowest common ancestor of a binary tree. Given a binary tree, find the lowest common ancestor of two given nodes in the tree. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes, P and Q, as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. So, just to explain this definition here, imagine we are looking for, as the example is asking, we are looking for the lowest common ancestor of P and Q, which P is 5 and Q is 1 in this tree here. So 3 is the root of this tree, and we are looking for the lowest common ancestor of 5 and 1. So we can think like that. Imagine the lowest common ancestor of 5 and 1 will be a node above both these nodes or one of them itself. So in this case, we have to look like that. 3 is equals to P or Q. No. 5 is equals to P or Q. Yes, 5 is equals to P or Q. 1 is equals to P or Q. Yes, 1 is equals to P or Q. So we found both the nodes we are looking for. So the thing we need to do right now is to look above and find the closest node to both 5 and 1. And in this case, it's 3. So 3 is the lowest common ancestor of 5 and 1. To solve this problem, we can use recursion, and we also can use a solution with some iterative way. But as always, recursion would make us write less code, so we will go with recursion. Our solution, let me see. I think our solution will do exactly what I just said in the explanation. So as this is a tree, we will start the iteration in the root node, which is 3. So let's try another example. Let's try an example where we are looking for the LCA of 6 and 4. Yeah, so we will start here. We will get to 5 and ask the question, 5 is equals to 6 or 4? No, 5 is not. Go to the next node. 6 is equals to 6 or 4? Yes, 6 is equals. So return 6 to the last call, which was 5, and continue it to the right side of the tree. So go to the next node, ask if 2 is equals to 6 or 4. 2 is not. Go to the next node, ask to 7 if it is equals to 6 or 4. It is not. It will go to a base case, which we need to check, a node that is null. So null is not equals to 6 or 4. It will return null to 7. It will try to the right side. It will get null again, return null. It will compare both results and return null to the last call, which is 2. Okay, it will go to the right side of the tree, check if 5 is equals to 6 or 4, which is 4 is equals to 4. It will return 4 to this node, and right now the current caller is 5, which in the left call it had a result 6, and on the right call it had a result 2. It will compare both results with any of them are not null, and this case means that we find the lowest common ancestor, which is the current color, 5. It seems to be a little bit confusing. Let's try to write some code and see if these get more clear. Let's see if we have other information here. So all nodes values will be unique. P and Q are different and both values will exist in the binary tree. Okay, so even if the exercise is not saying, let's check if the inputs are valid inputs. So let's try if root is not null and P is not null and Q is not null. Actually, here is equal. So if root is equals to null or P is equals to null, yeah, we are checking here if any of our inputs is null, because if any of them is null, we will not find the lowest common ancestor, and in this case, we will just return null. Okay, so as we already checked the inputs, we can just start the call of our recursion. So the exercise is asking for the tree node, the LCA tree node, so we will just return the result of our function. So our function we can call LCA, and the function will use all the inputs that we have here. So root, P, and Q. Okay, so let's code this function. So private tree node LCA tree node root tree node P tree node Q. That's right. As this is a recursion, we need to first check the base case. If not, we will get in an infinite loop and our program will crash. So what is the base case here? So I think the base case is also close to the base case in the function above, with the difference that we will not check P and Q because we already did, and we will not manipulate P and Q. We will just manipulate root here. So we just need to check if root is null, because if the root is null, we can't compute anything. We will just return null. And this case here is exactly the case where I showed you here when we are in a leaf node, and leaf nodes here are 6, 7, 4, 0, and 8. The recursion function will try to call the next node which doesn't exist, so it will return null, and this is the case that will protect us in this scenario. Okay, so as here in the line 23, we know that root has a value, so we can check if root is equals to the nodes that we are looking for. So if root is equals to P or root is equals to Q, we can just return root, because this is the case that we saw here when we find the node that we are looking for. So in the example, P is equals to 5 and Q is equals to 1 is here. We are in the root node. Root node is not equals to 5 or 1. it gets to the next call, and 5 is equals to 5 or 1 is exactly what we are checking here. So if 5 is equals to 5 or 1, return to the last call. And now is the case that 5 is not equals to 5 or 1. So we need to look to the next node in both sides. We need to look to the left side and we need to look to the right side. And now our recursion will start. So for the left side, we will call the LCA function, just passing the left node of these three, and pass to the next call the same P and Q. As I said before, we will not manipulate P and Q, just the root. So we need to do the same thing for the right side, and also pass the right node of the tree. Okay, so we just did what we said before. We need to call left side and right side of the current node, and this is been doing here. Let's see the next step. So the next step is, imagine we get here in the node 6. The node 6 returns us it returns us itself because we find a node that we are looking for, and yes, but the code don't know. We need to check this. So how can we check this? Because we need to check both left and right to see if both of them returned something that is not null, or even if it is null, we need to be able to handle this. So let's think. Okay, let's see the example where P is 5 and Q is 1. So the left side will return 5, the 5 node. The right side will return the 1 here. And to get to know if we are in a node that is the lowest common ancestor, we just need to check if both results is not null. Okay, so this is easy. We can just check if left is not null and right is not null. So if left and right is not null, we can assume that the current node that we are is the lowest common ancestor. The example that can show us this is the same example that we saw before. P is 5, Q is 1, 3 is the current node. We call the left node 5 and we get here 5 return us the value of itself. The same with the right side of the tree, and we are here just now checking if 5 and 1 are not null. So as they aren't, we just return root here because we just find that 3 is the lowest common ancestor. If any of these cases returns us true, we just need to continue our calls in the stack. So to do that, we just need to check if any of the nodes are not null. Here we check if both are not null. Now we need to check if any of them are not null. So we will try to return the one that is not null. If this is not possible, if both are null, we will just return null. when both are null is the case that we are in a leaf node, where both calls will return as null. So we can just return checking if right is null. We return left, otherwise we will return right itself. Let's give a second look here. I think that's it. If we don't have any typos, this seems to be the solution. Let's try to run. Okay, that's it for this scenario. Let's try to submit. Yeah, that's it. So this is the solution for the lowest common ancestor, and that's it for today.